It begins again.
Hello.
Oh, Joost is here as well.
Yeah.
Eric, stop crying.
Oh yeah, mommy, mommy.
Well, just FYI, I'm recording this, because
Yeah.
be able to make it.
Is it about again?
What is it about? It's about naked chicks.
Oh.
Good, good.
See, everybody's interested already.
Except you.
You had to say it, didn't you? You had to.
Yes.
Where are you, Joost?
The office. The best place there.
What is it?
Is someone sharing that?
Oh my god.
What's this?
He did hear this is recorded, right?
Oh no.
Oh, this.
Who's doing this?
Joost, of course.
Oh.
Am I in the right meeting? Or...
Okay.
Maybe I should stop recording and record.
Yeah,
Stop
leave.
it.
So it would be fun if you were watching.
What have I joined?
Oh,
My god.
this is not good.
No.
Okay, maybe restart.
It's too late now.
Take
Okay.
two. Like.
We'll keep it.
Yeah.
Oh god.
There were no racist stuff or anything bad like last time, remember? Last time it was a disaster. We had to restart.
Oh.
So, how was everybody's day? Were you productive?
Very
Yeah.
much so.
No.
I was screwing with Word all day because it's a horrible software program. I hate Word.
You
That's
hate
basically,
Word.
That's basically my day.
Not a good punchline.
I hate Word.
So, are we gonna wait for more people? I guess.
This could be it.
Luigi and Marlijn are not there.
Where are they? I see.
And Diederik is not coming, I think.
Yeah, Diederik cannot come. Marlijn, I don't know.
No, she isn't. She had things to do.
Thanks.
Thanks.
What's more important than watching my presentation? Sorry.
A lot.
Ooh, Derek. Derek? Come on in.
Where is he? Oh, hello.
Hello.
Hello. And Joachim.
Welcome.
Nice. Well, we'll give it one more minute, and then we begin. Need time to prepare.
Oh, where's the cheat sheet?
The cheat sheet was on the... in the... let's say this? In the schedule, like the invite. I attached.
Oh, you had one?
Yes.
Ah, I didn't know that.
Someone already find it?
In the stand-up.
Yeah. I was looking for it.
Yeah.
Find it.
Yeah.
Oh, but can you still find?
You mean on this invite, right? Because I couldn't find it either.
Yeah.
Okay, so it's not just me.
Yeah, I can't find it either.
Yay.
Yeah, it's Billy's problem.
Yeah.
No, it's your problem, actually. I know my...
Where can we find it, Billy? We're so...
It's on the schedule, like on the planning thingy. You know, on the schedule, on your calendar.
Yeah, I have it open.
And it's not there?
I don't know where to look. Insert, maybe.
Okay. Well,
In this meeting, under files or meeting notes?
I don't
No.
see it.
Okay, well, give me 1 second. I'm just gonna put it in the message here. Uh-huh.
Oh, how do
You fucked up already.
Language.
Everything that you say will
Will be
be
recorded.
will be recorded and used against you.
Yes.
What are you eating, Derek? Broodje pom?
No, broodje egg.
Okay, I'm trying to attach this, but I cannot.
How difficult is it?
Well, you tell me.
Yeah.
Otherwise, you throw it in the chat.
I'll put it in Geek Squad. Yeah, it's in the chat. I'm trying to put it in the chat, but
Oh.
it won't let me. Anyways, I'm gonna put it on Geek Squad, and please share it to the people who don't have access to Geek Squad.
Cool.
Oh shit! I opened it.
Oh no.
All right, it's on Geek Squad. Okay, let's begin because if we don't have all day, and I'm sure you have other stuff to do.
No.
Toch? I want to have a screen to watch everybody. Everybody go on mute, huh? I don't want any distraction. You too, Rick.
Fuck you.
Anyway, I'll pretend I didn't hear that. Does anybody want subtitles? I don't know. Maybe you want subtitles? No?
No.
Okay, I'll switch them off.
Dutch.
Anyways, good afternoon, everybody. Thank you for joining this amazing presentation on OAuth 2.0 and OpenID Connect. I'm sure you're all familiar with the terms. Basically, this is a knowledge sharing session, and well, I would like to talk a little bit about more about these protocols. I know they've created a lot of headaches to many developers, but luckily most of the implementation of these protocols has already been done by Colton Identity Server, you know, by yours truly. So you won't really have to set it up and all this, but it's good to know like general concepts and how they work. So in this session, I will not really go through how Colton Identity Server is built, but rather describe a little bit the protocols that are in use behind the scenes. So in this session, yeah, it's going to be mainly about OAuth 2.0 and OpenID Connect. So let's see. It is my hope that by the end of this session, you will have learned a little bit more about these protocols and will find easier to work with in your work. Like if you want to connect another app or if you want to link other customers, etc., like users, log in, log out, blah, blah, blah. So it's not working. So what are the goals of this session? At first, I would like to discuss what OAuth 2.0 is and how it is used. We'll go a little bit over the history and try to understand the reason why it was invented. Invented, right? Secondly, what is OpenID Connect and how it relates to OAuth 2.0? Of course, many people find these terms a little bit intimidating. And yeah, you can see it's chasing people away. Not because they're super hard, but because there's a lot of junk out there, and really people get confused all the time, like including myself. Like at the beginning, I would see all these terms and I didn't understand anything. You know, I had to watch a lot of videos and trainings and stuff like that. So luckily, I've condensed all the information in this. So next. Yes, we'll try to understand a little bit more about the terminology and finally try to explain the different flows that exist. So, ladies and gentlemen, please sit back, relax, and enjoy as much as you can. Okay, let's talk a little bit about ancient history, namely before 2010, I think, something like that. Back in the day, people used to authenticate using simple login forms authentication. That was basically a homegrown authentication, and it was pretty standard. Like you had the username, password, and it would like talk to a database. It would hash the password and then verify the hash, look up the user info, and then look up authorization info. I mean, everybody's familiar with this. Like everybody also, I guess, tried to do this like a homegrown solution from themselves and dramatically failed. I think most of us, anyways. Yeah, in the end, it would just get a cookie, put a session ID, and then put like a time limit or a duration, whatever. Now, of course, there was a big downside of that. And what was it? First of all, was security and maintenance. Now, can anybody say why there is a big downside on security and maintenance using that way? Anybody? Just talk. No? Nobody?
Rainbow tables.
Nice. The maintenance and security?
Multiple systems.
Multiple systems. Yeah, multiple systems, you mean like you have like two different applications and you have to implement the same thing in two different places. So that means different username, different passwords, right? Is this what you mean?
Yes, that's what I mean, Billy.
Yes. Anyway, go back on mute, please. Yes, thank you. All right, so yes, OAuth 2.0 and OpenID Connect are becoming the industry best standards for solving these problems, but there's a lot of confusion about OAuth 2.0, like I mentioned before. So basically, there's a lot of terminology and jargon all over the internet. So if a newbie, such as, you know, I wouldn't say yourselves, but yes, thank you, gentle. So if a newbie tries to Google some search results or whatever, yes, you too, Joey, yes. Maybe Christian, Joachim. Okay, I won't mention any names, thank you. So if you go on the internet and you try to type like to find some information on there, you'll find guides and explanations that assume you already know most of the terminology, right? Like they will talk to you about the resource manager and the resource owner and the authorization server, etc. and blah, blah, blah. So they will assume that you know most of the jargon. There's also a lot of incorrect advice. There are many different opinions regarding the usage of the implementation. Some developers may disagree with others or agree with some. Like you have one implementation and everybody supports it, and then suddenly you have a developer saying, yeah, this is not the correct way. You should do it like this according to the books. But the books are not really, they're pretty abstract, you know, so you don't really know. So in general, there's a lot of wiggle room when it comes to OAuth and authentication and security. So this is what we'll be showing today. Okay, now, I think it was around 2006 or 2007, let's say 15 years ago. So let's go back there and see how identity use case looked like, all right? Now, 15 years ago may seem like pretty recent, but it's a lot of years in computer history, right? Like even 2 years, if you get a laptop right now, after 2 years, it's like basically obsolete. So imagine how it is with software. A simple login form was the one that we all know and love, of course, and many people try to implement it on their own. Single sign-on was a very good protocol, SAML. I'm sure some of you are familiar with it. An example of that would be Active Directory or something similar. Correct me if I'm wrong, but I think that's correct. The downside of this one was that it's harder to work with, like even harder than OAuth 2.0. So don't get into it. It caused me a real headache. Yeah, then mobile app login, I put a question mark because practically back then it was the moment where everything was starting to develop, like with mobile. So there wasn't really any standardized way. So people were just inventing things, right? They were just creating simple user login forms or whatever. It wasn't like a really standardized way to do all those things. Go further down. Yeah, so in this case, they had to solve issues like how to keep a long-running session open on the mobile, because people who just wanted to open, see, close it, and then use it again after like 10 days without having to re-log in, etc. The last part is delegated authorization. Back then, it didn't really exist, but this is what we'll be focusing today. You do understand this, right? Delegated authorization. This is where OAuth was actually born.
No, I don't understand it.
Delegated authorization is like when you authorize an application to access some data on your behalf. So you delegate this application to access the data.
That makes sense.
Right? This is a very common pattern now, but a few years ago it wasn't really available. This is OAuth 2.0, by the way. So, why was OAuth invented? Okay, for the younglings, you can just look away. I don't know if you actually remember this, but I found this really nice picture on a video that was actually showcasing a little bit about OAuth and why it was used, and I thought I would use it. So, does anybody remember Yelp? It's still active now, but do you remember it back then? I mean, like 10 years ago.
That rings a bell.
Yeah. What? Who can tell me what's wrong about this screen, this beautiful screen here? Well, let's analyze it, shall we? Now, your email service, MSN, Yahoo, AOL, and Gmail. Basically, you want to connect to Yelp, right? You want to leave a beautiful review. Joost, did you want something? You can just talk,
Yeah, I know, but you ask what's wrong with this?
Yes.
That you're probably gonna submit your credentials to that service, through that service, instead of.
Now, don't get me wrong. I don't care. I mean, I don't have anything to hide in my personal account, but Yelp back then was probably like a startup or something. So I don't think anybody would really trust it 100% to give their credentials to them. So basically what Yelp will do is get your credentials and remind you here that the password you use to log into your Gmail account, right? So you would provide all this information and they would go into your email account, they would get the contacts that they need, and then they would use them on your behalf, right? So they would actually log in as you, the user, in there. Now, this was, okay, they tried to solve a problem, but they created another one on the way. So I don't think that, I mean, I never did that. When I saw this, I was like, okay, even though I didn't have anything to hide. So, by the way, I don't know if you're familiar, in the States, some tools actually still use this. You have YNAB, I don't know if you know it. You need a budget. Well, if you're in the States, you can actually put your login information of your bank account, and they will log into your bank account on your behalf and collect all this information and then spit out reports. Many banking systems are still doing this. Mint is another example. Yeah, this is bad. I wouldn't do that. Okay, now let's see how we would solve this problem with OAuth. I'm sure many of you know this, but let's watch it from like a higher level. All right, so delegated authorization with OAuth 2.0. Let's meet, for example, Karen, our favorite Karen. Now, Karen is a very concerned Yelp.com user who feels the urgent need to register on Yelp, okay, to provide her very valuable review about a local diner. She has a lot to talk about, right? So notice how the login here says login with Google, right? Now, Karen already has a Google account and she really trusts Google. So what is she going to do? She's going to click on the account and she's going to be redirected to, how is this called? The Google Authentication Server, where she's prompted to log in using her credentials. If you notice up here, karen.preaches.nonstop@gmail.com. So after she logs in, she will be redirected to the consent screen, where she's prompted to allow Yelp.com to access her information. So basically, you can see here, she says, read, send, delete, and mess with your mail in general, and harass your contacts and make them hate you, whatever. I mean, it can be any permission you want to give them. So as soon as you click allow here, yeah. Yes, as soon as Karen accepts, she is redirected back to Yelp in the callback or redirect URI. And after this, Yelp is allowed to access her contacts and gather the information they need, right? Why would they ask for contacts? I have no idea. This is what they do. That's what they need in order to write reviews. So bear with me, okay? Just believe it. Let's believe it's true. Now, okay, so far I'm sure you've seen all this this flow before. You know that it's happening on the internet right now. This is OAuth 2.0 basically. So let's analyze the terminology used in the previous example. So let me show the list. Yes, right here. Open question. Who is the resource owner?
Billy,
What?
maybe you can explain what the difference is between authentication and authorization.
Right now
Because
we're doing authorization. This is OAuth 2.0. It's authorization. Authentication comes later.
okay.
When we're talking about OAuth 2.0, I should have said this before, sorry. It's all about authentication, authorization, authorizing an application to access data.
But because the terms look sounds like really the same, but I had a lot of trouble with it. What the difference is if you don't carefully watch what it is.
Yeah, I do actually explain it further along, but for now it's only authorization, authorizing an application to access information, not authenticating. We're not authenticating who the user is. Okay, I just showed.
But you do provide your credentials, right? So you are being authenticated as well.
Yes, because somebody needs to authorize the application. So the person authorizing the application has a credential, so they need to put it somewhere. But at this stage, we're still talking about authorization, putting their credentials to authorize this application to access some data, some information. Is this clear?
Yeah.
Yeah? Okay, so who is the resource owner in this case? Can anybody say? In the previous example.
Was it Google then?
It's Google.
No.
New?
No. Resource owner.
Yelp.
Sorry?
Yelp.
No.
Yelp. Yelp.
Karen.
Karen.
Yeah, it's her Google account.
Yes, Karen is the resource owner. She has a resource to provide, contacts, etc. Who is the client in this case? Now, this is the terminology I was talking about, right? Client in OAuth 2.0. Can anybody guess?
Isn't it?
It's Yelp. Yes, precise. Well done. And who is the authorization server in this case?
Then I'm going for Google.
Yep. We have Google. This is the winner. Who is
What an
the...
effect.
Eh?
I said, what an effect.
Oh, shit.
Okay, Google.
I didn't realize it was a GIF. Wow, look at it going. Nice. Okay. What's next? Resource server, I think, huh? Yes. Who's the resource server?
Gmail.
Yelp.
Actually, no. Joost is semi-right. Anybody else? Because we're accessing two stuff. The authorization server is the Yelp is requesting access to two areas, but in the end we accessed only one, and that was
Contacts.
Yes, that was Google Contacts. Now it can be the same as the authorization server, but it can be something entirely different, something we're trying to protect. In this case, a resource server, like a resource we're trying to protect. What about authorization grant? What is the authorization grant in general? This is a bit tricky.
A grant, like granting permission?
Yes.
So it's the one granting permission? So Karen again, or?
Karen, yes, but it's the act of actually allowing this. So this is
consent.
Granting, consenting.
Read contact.
Yes. Sorry?
Read contact.
Yeah, you're actually allowing the application to do those things up here. Once you allow this, you're providing an authorization grant. And here, what is the redirect URI?
That's the callback, right? After you allow it.
Yep, this is the callback endpoint. It's yelp.com/callback or something else that you define in this case. And last but not least, what is the access token?
The thing that's sent back with the or to the callback URL, I guess.
Almost, not always, sometimes.
Okay.
To me, it sounds a lot like the authorization grant.
The authorization grant, well, basically this is the key, right? It's the key that Yelp needs to access the contacts. So the access token is the key in this case. I mean, what you said, Derek, is true, but I will explain it later. It depends on the flow that you're using. If you're using a code authorization or implicit flow, right?
But so in this case, the token is sent by Google to Yelp.
By Google to Yelp. Yes, and I will show the flow now. Let's look at it again. So this is the authorization code flow, okay? Remember Karen, she clicks on Google login thing. She's going to the authorization server with a redirect URI yelp.com/callback. The response type you notice here is code. Now, she's entering her credentials. She's going to the consent screen. And once the consent screen is allowed, we're going back to the redirect URI, but this time with an authorization code because we're requesting a response type code. Now, what happens at yelp.com/callback, there is an exchange of the authorization code for an access token. So Yelp actually goes back to Google and says, here's my authorization code, give me a token. So he gets the token back, and using this token, he can have access to the contacts, right? Is this clear?
So there's always two calls between the one who asks and the one who authorizes.
There's always two calls. Yeah, not always. In the authorization code flow, there's two calls, yes. But this is only done once. Huh? Once you get the access token, it is saved here, and then with every request to the contacts, you have the access token. You don't need to get a new one, unless it expires. Comprende?
Yeah.
Fair enough.
But if it expires, isn't that also handled automatically? Like
Not always.
Okay.
Not always. If it expires, you'll get a 401, so you'll be forced to be redirect back to the.
Okay, yeah, I thought there was some part of this where you'd bypass a lot of this extra.
You can bypass it if you use refresh tokens, but it's not the scope of this presentation. So if you want more, you'll go and find the information you want yourself. All right. Now, in this case, the authorization code is actually useless, okay? The client needs to make another trip back to the authorization server to exchange it for a token, like we said. So the authorization code is an extra security layer, let's say. It's the access token that allows the application to perform certain things. This is the basic thing, okay? That's what every flow is about. Now, every flow describes this particular flow, but with slight variations, which we'll see further along. Now, I have a question. Do you know how does the client, Yelp.com, specify what it wants to do at Google.com?
We're talking about scope?
Yes, exactly, using scope. So we've got some more terminology in this case, scopes and consent. Yeah, because I didn't talk about consent before. I briefly mentioned it. But the authorization server contains a list of scopes that it understands, okay? Permissions, if you like. When the client makes a request along with that, he requests a list of scopes. Get it? So when you make the request, the initial request, you say scope equals this, 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 this. So I want access there, 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 there. Now, depending on whether or not the authorization server will allow you to do that, it's a different question, okay? You can set it
So
up.
what was the scope in the previous example then?
Let's see
Google
now.
context.
So the scope, in this case, comes here. Scope email and contacts. So Yelp is asking for access to the emails and the contacts. So once you go here, once Karen goes here, and logs in, the request consent form is being generated using those scopes. Okay, you understand? Okay. Now, once the access token is generated, it is limited to these scopes here. Now, what is the point of, this is actually my previous question. What is the point of getting an authorization code first and then exchanging it for an access token? We said it's an additional, like an extra step, an additional security layer, if you want. But can anybody explain why?
I don't completely follow your question, but is it like you get first an access token, and with that access token you don't have the data yet, and then you request the data?
Sorry, maybe I missaid my question. I mean, first you get an authorization code, and then you exchange it for an access token. We did say that this is an extra security layer, but do you know why it is happening? Like, what's the point of doing this? And how is it going to protect us? Anybody?
To be aware of what you consent to?
No, the authorization code does not provide this kind of information.
To have an access token which won't allow access to, for example, YouTube or something?
No, this is the scopes. That's the scopes. The scopes will define what kind of token you'll get. Well, let's have a look. Has anybody noticed anything about this?
Isn't this to do?
Say it, Christian.
Yeah, I'm just trying to form the words.
Form the word.
But requesting the access token isn't coming from the same place that you're requesting the authorization code, is it? Isn't that kind of the point that you're not?
It is actually.
Oh, is it?
It's coming from the authorization server.
Oh yeah. Oh, shit.
Now, if you notice closely to the diagram, you have some red arrows. Now, you also notice the dash and solid lines. Okay, so I put different colors on them so that you can see it better. Here we have the green ones are the back channel. It's what we call the back channel, and the front channel is the red ones. So basically, the whole flow is in the front channel, and the front channel is less secure than the back channel. Now, what's the difference between them? The front channel consists of browser to server calls, and the back channel consists of server to server calls. Right? When you have two servers in the back talking to each other, that's a back channel call. And when you have your browser talking to a server, that's a front channel call. Now, the reason we use the authorization code is because most of the communication is done in the front channel. This communication is done between the browser and the server. Sure, it is secure, but even the encrypted information can leak and be intercepted by hackers in your network or whatever, you know. So as long as it's in the browser going to the server, within your network, it can be intercepted. When it's server to server, it's a bit more difficult to be intercepted. It's going to be somewhere far away, maybe not in the same continent. The back channel involves communication between servers and usually cannot be intercepted. Okay, so we could say that it's a bit safer. Add to that the additional security like HTTPS or SSL, then we can say that we trust it more. Okay, so if we take this example, nobody really cares about scopes or the redirect URI or the authorization code inside the query parameters. They cannot really do anything with this. The exchange, however, happens to be in the back channel. Now, if somebody intercepts the request, they can see the code here. They can steal the code, sure, but they can't really use it because the exchange happens in the back channel, you know. So even if they have the code, they will never be able to exchange it for a token. This exchange here, it includes a how do you call this? Fuck, I forgot.
Client secret?
Yes, thank you. The secret key and the client, client ID, which is some additional security provided by the authorization server at the time you register your application. Okay. Also, usually the requests with the resource server here it also happens in the back channel, you know. So the token is sent, but it's also, let's say, semi-protected. Just remember, access. Yes.
Can I reformulate this to see if I understood correctly? So both the client ID and the password and the secret are kept in the backend, and therefore it is safer, like added as a salt to the password.
It is safer because, yes, when you send them back to the server, you send them from a server to another server, so it's using the back channel, right? So,
yeah, so the client ID never arrives in the front end.
The client ID may arrive in the front end, but the secret should never arrive in the front end. That's why when you say code flow, it is usually used for applications that have server-side code as well, or a back-end server. Now, the access token, remember, is very sensitive information and it must be kept safe. So when you get an access token, you save it somewhere in the server, and then all the communication should be done in the back end. Let's see, next slide. What do I talk about there? All right, let's have a look about the OAuth 2.0 flows. I'm sure you are familiar with them. You have the authorization code, which can be used when you have a combination of front and back channel, okay? So you have a front-end application with a back-end server. So that's a combination front and back-end channel. The implicit flow, it can be used when dealing with front channel only, okay? Now this flow skips the exchange entirely. It just gets a token right away. It is less secure, of course, and it is only available for front channel. So that means pure JavaScript applications or SPA applications, like only front end without a backend server. Yes?
Without a okay. Could it be just our Swagger, maybe?
Swagger, yes. Yeah.
Because then we just want to have a token that we send.
But wait a minute, no, the Swagger will contact the backend server, right, to get all the information. You have a UI, but then you contact the backend server.
Yeah, but Swagger will just send a bearer token, and that token, it can get through the implicit flow.
It could, yeah, but then you have the token exposed to the server, to the browser, and you don't really want that. When I'm talking about only JavaScript applications, like just JavaScript, you don't have a backend, you know, it's serverless. It's an SPA, for example, like an Angular application, you know, which is only front end. Let's say you don't have a backing server. In that case, you would use implicit flow. There are some use cases where you can do that. You can find many examples online. I cannot name right now which we could use, but implicit flow is usually only when you don't have a server to back you up. Brende.
So the flow that you just explained with Karen, let's say, that's an authorization flow example of the first bullet point, and the second one is just something different. Or
say that again. I didn't hear you.
Yeah, my sound is terrible. Sorry.
Yes.
The whole Karen flow before, that's an example of number one?
Number one, yes.
Okay.
You get it? I will show the implicit flow now, just to make it clear. But there's one more, the resource owner password credentials. This is usually used for back channel flows only. It's not for front channel flow. And it was designed mainly to support older applications who have a username and password login, you know. For example, we did it at the NOP Commerce now. The old application used to have like people logging in using their username and password directly on the website. OAuth 2.0 offers the authorization server, but we didn't want our clients to be redirected to another server, log in, and then come back to the website. We wanted to have the same experience. So in that case, we used resource owner password credentials. Like I said, it's to support older applications, but it's not really recommended for new applications. So eventually, we're going to have to change that. Okay. Client credentials is a back channel only flow, and it involves server-to-server authentication. So when you have like NOP sync sending information to NOP commerce, when you send products, That's a client credentials flow. Okay, did you understand the examples? You all look a bit like, huh? What is he talking about? Okay, laughing's good. Next, let's watch the implicit flow now. You will notice that the entire flow is in the front channel. Okay, there's no dashed lines. Now, our favorite character, Karen, is going to yelp.com, log in with Google. The authorization Yelp redirects to the authorization server right away, but this time the response type is token. It's not code. And the scope is email and contacts. She logs in Google, she gets to the consent form, and then, because the response type was token, it sends her back to the redirect URI with an access token. Okay, and then, yeah, she can talk to the resource server from the front channel to the back channel using the token. This is less secure, but in this case, Yelp.com doesn't have a server backing it up. It only has like the beauty, like the front end stuff, and then it gets some information from Google contacts, and that's it. It doesn't do anything else. Maybe it does, but it's all front end. Okay? Any questions here?
I still see use case for Swagger here.
Yeah. There could. This is the type of disputes I was mentioning at the beginning. In if you go to Stack Overflow, you know, some developers think that this is a use case where you would use that. Some others think otherwise. So it's pretty open, right? It depends. I think that Swagger has a server in the back end, and that is the application you're designing. Others think that Swagger is just a client that provides information about what you've built in the back. It's not actually dependent on the back. So what you have in the back is not Swagger's, it's yours. And Swagger is just showing it. So yeah, you could use implicit flow. I wouldn't use implicit flow. But again, it doesn't really matter because Swagger is something internal, right, for developers. So maybe implicit flow is good. I don't know. It's open to debate. Next slide. Anything to add?
Yeah, the only thing I heard is that some people noted that it was less secure. So yeah, if you want a one-size-fits-all solution, you might not want to choose implicit flow.
Yeah, implicit flow in general is less secure. Yes, you can, but Swagger provides the opportunity to paste the token directly on the UI. So that's already less secure, right? So yeah, implicit flow should be fine in this case. I don't like it though, but whatevs. Anyway, now let's see what happened after OAuth 2.0 got adopted. So it got adopted really fast as a standard, and you can understand why. I mean, it's so exciting. Everybody wanted to start using it. So suddenly this protocol provided a new, better, more secure way to authorize applications to access private user data. Then as the demand started to change, people started using it for other use cases, as you can see here. Now, you see here authorization, right? OAuth 2.0 was designed for delegated authorization. It has nothing to do with authentication. And these other three standards were specifically for authentication, right? To identify who the user is. Simple login form. Who are you? What do you want? You know, log in using your username and password. So OAuth was not really designed to be used for authentication, but of course people are very resourceful, so they created lots of different hacks. You could have seen that back in the day when Facebook started using this type of authentication. So you would have all these crazy claims that, yeah, this application would like to have access to your account. Very generic, you know, like you don't know what it's going to do. So would you like to access it? And then you would use this the same way to log in to a different application. So it was pretty much a hack. So using OAuth for authentication is bad, because there is no standardized way of getting the user information, such as email, name, or whatever, you know, whatever you want to get from the information. It was only designed for application permissions, so delegated authorization. It was designed basically to allow other applications to access information on your behalf. That's it. So as a result, there were many different implementations by different providers, such as Facebook. I think Google also had a different authorization standard. I don't know. It was not really standardized. So naturally, people started thinking of a better way to deal with it and to make it a bit more standard. And what happened? Can you guess it?
OpenID.
Yes. Did you hear the thing?
No, there was no sound.
Oh shit. Okay. I put a yay. You know.
Oh, we will help. Yeah.
Yes. Thank you. Thank you. There you go. More people, please. No. Nobody. A heart. Nice. Okay. I like it. I like it. So OpenID Connect is the savior, right? Basically, OpenID Connect is not really a new protocol, but rather an extension of OAuth 2.0. So it sits on top of it. Let's see how. Now, OpenID Connect adds the following. As you can see here, an ID token, which contains some information about the user, a user info endpoint for getting more user information in the case that the ID token doesn't contain enough information. And it contains also a standard set of scopes, such as OpenID, profile, email. I think there's a couple more, but we'll get into them later. No, we won't, actually. I'll give you some resources so you can get into them. I already know them. And a standardized implementation for allowing this type of flow. So, next. Yeah, so OpenID Connect is for authentication only, and OAuth 2.0 is for authorization. Now, authentication is authenticating the user, like who is the user and what does he want, and authorization is authorizing the user. Is the user authorized to access this, or is this application authorized to access this area? Comprende? Okay, silence means yes.
Yes.
Good. Now let's see how OpenID Connect flow is like now, you know, using the previous example with our dear Karen. Okay, so if we have a look at our dear Karen here, she's so pretty. We will notice that this time the scopes include OpenID and profile. This is a standard scope which provides some additional information about the user, okay? So OpenID provides information about the specific user. This is an OpenID Connect and OAuth 2.0 request, okay? So it includes both because OpenID Connect sits on top of OAuth 2.0. And yeah, in the end, we can also get some additional user information using the access token. So when we get the access token here, using the access token, we can call back the authorization server, and then we can get an ID token and an access token. The ID token is basically a JSON web token or a JOT token. That's how we call it. And we can go into a few details about the token now. Do you have any questions here? Another difference is that here you can see that Yelp now knows that this is Karen because OpenID also provides the first name, last name, or whatever of Karen. So he says, welcome, Karen. Please give us your best review. Okay, let's talk about the anatomy of a JOT token. Interesting stuff. Okay, so we have the header, which typically consists of two parts. The type of the token, in this case is JOT, JWT, and the sign-in algorithm being used. Now the sign-in algorithms are HMAC, SHA-256, and RSA. The second part is the payload, which contains the claims. Claims are usually statements about the entity, or in this case, the user, and some additional data. There are three types of claims. You've got the register claims, public claims, and private claims. Let's see which one is this? Yes. Okay, so registered claims. These are the basic registered claims, like the issuer, expiration time, subject, audience, and some others which are like very standard.
Sorry, Billy, is claim just another word for info? Like, I know what the word claim means when you like claim something, but why is it called claim?
I'm sorry, I think I forgot. I skipped this. We talked about scopes before, right?
Yeah.
The scope usually contains a list of claims. When you talk about a scope, it's basically a list of claims. Now, an OpenID scope is a list of claim of the first claim is first name, second claim last name, third claim email, fourth claim whatever, age, you know. So a scope is a list of claims, and this is what you get in the token in its rawest form, right? These are a list of claims, and then the registered claims are some standard claims that are being sent along with the token.
So properties, basically.
Properties, yes. Information about the user or the entity that is using this token. If it's an ID token, it's about the user. If it's an access token, it's about the client, like the application that requested the token. Does that make sense?
Right. Yeah.
Yeah. Yeah, or yeah.
Yes.
Good. Okay, then what's the next one? Oh, yes, we have public claims. The public claims are defined at will by those using the JOT tokens. To avoid collision, they usually should be defined in the IANA. You can see it here, IANA.org. This is the IANA JSON Web Token Registry. Or they should be defined as a URI. Sometimes you have some tokens, some claims that look like a URI, right? They're pretty long, and this is to avoid collision. And that's how they call them collision-resistant namespaces, so that you define a claim and somebody else did not define the same for something else, right? Does that make sense? I think I'm getting too deep here, but you're smart. You'll take it.
Sometimes you need to show something.
To what? To share.
No, show. I mean, show how a yacht actually looks like. But I think you'll go there.
Oh yes, yes. It's in the next screen, but you know, too graphical. It's too pretty. Where was I? The public claims. Yes. Private claims. The last one was private claims. Yes. So private claims are the custom claims created to share information between parties that agree on using them. Okay, so that's let's say that I made an agreement with .control, Derek, my friend, okay, and he says that he wants to use the, I don't know, some additional information about the user, like his age, okay? Right now we have date of birth, but I want to know his age. I don't want to be able to calculate it on my own, right? So that's a private claim that I will be defining along with him, and we will agree that our token is going to include this claim. And this is the age of the customer in this case. Okay, now this is the payload. Finally, we have the signature. Now, I don't know if this is a bit confusing for most people, like what the signature is. The signature is usually used to verify that the token hasn't been tampered with along the way, right? And in the case of token signed with a private key, it can also verify that the sender of the JOT says who he says he is, right? So I request a token from my server. The server authenticates me, and he knows who I am, and he gives me this token, and he signs it. Now, if I take the token and I change something about the token, like the claims, or I add something else in the token, then the signature also changes automatically. So once I do the request with the tampered token, the receiving, so the resource provider will verify the token using the signature. So without even having to go back to the authorization server, it's going to see that the token has been tampered with, and it will no longer accept it. This is like an extra.
So it's like a hash within the token?
Yes. Right. Now you can see it here. Putting it all together. Oh, it's quite small now. Can you see it? This is the the signature, and there's a secret here in the middle, and this is how it is saved. Let's say, so you have the top, which is the header, then you have the payload and the signature. And if you want to verify your token, well, to check your tokens, you can go to jot.io and you can deconstruct them, decode and encode them there. Ooh, Eric is a bit anxious, like, okay, come on, let's finish.
No, I'm a bit tired.
Oh my
and
God.
a bit cold.
Oh my God. Okay, there's 6 more slides.
No, I like it.
Okay,
keep on going.
Bear with me. All right.
But a question, right? If I may, to call
Hey.
the signature a hash is a bit simplified, right? Because it's to call the signature a hash.
Yes.
That's a little bit simple to describe it like that, right?
I said this is a course for dummies. Yes, it's very simple. Thank you, Rick.
Yeah.
No, it's not that simple. No, because there's some very complicated algorithms being done, like hashing those values and creating those secrets in the back, and they all depend on the entire token, right? So it's not completely isolated, and it was designed that I'm not even going to pretend to know how it was designed, okay? But it was designed that way so that if you try to change anything here or here, then the signature will also change. It will no longer map to the header and the payload. It will map to something else. So it's like telling you, for example, when you put a password in the database, you see the password inside saved, persisted in the database, is changed, right? It's a hash. It's a long hash that has been encoded by the computer, by the server, whatever. So if you try to change this somehow, it's going to change completely from what was the original code. For example, you have secret, and then you have a long ass hash. If you change this, it's no longer going to be a secret. It's going to be something completely different. And I think this is how they map between the header payload and the signature. That's how they verify that they're not tampered with. Okay, I'm not sure exactly how it's done. If you want, you can go to, I have some resources in the end where they explain a lot of shit. I've never read this, so I don't know. Let's see. Now, let's have another look at the identity use cases today. As you can see, the simple login form, single sign-in across sites, mobile app login, all use OpenID Connect now, and this is for authentication. And the delegated authorization uses OAuth 2.0, and that's only for authorization. Let's see. So the use of OAuth 2.0 is for granting access to your API, getting access to user data in other systems, okay? Like getting access to user data from other systems, I meant. And then you have the use of OpenID Connect is for logging the user in and making your accounts available in other systems. So basically logging in and getting an ID token with some information which you will provide to another system. Okay, now let's take all this and apply it a little bit to Colton Identity Server. Now, in the next slide, I have like an example, which can be found in the identity configuration. Where is this? Here's a namespace. It's inside the data initializers. So basically, this is run every time you run Colton Identity Server. And because everything is static, I didn't have time to persist it to make it like dynamic. So this will happen in the future, but for now it's static. And whatever we want to add something, it's going to input it in the database from here. Now, as you can see up here, the identity resources are the user resources that we are aware of. Each one of these scopes are actually groups of individual claims, like I said before. So the OpenID is the standard OpenID Connect claim. Then you have profile and email, the same, and we can add more. We can add here, for example, an identity resource called Colton customer, right? And Colton customers may contain additional claims such as customer ID, or if he's a good paying customer, maybe he's bad. if he's whatever, okay? So these are the claims and scopes we can define for ourselves, and these will go under identity resource. Here, the API resources are basically individual APIs we are trying to protect. I think I have an example of this. Yeah, so yeah, these are the APIs that we're trying to protect, endpoints or resources that contain information we need to access from other applications. API scopes are pre-agreed upon scopes that involve the application and not the user. As you can see here, NopCommerce, Agent Payment Gateway, Integration Gateway API. These are scopes that are agreed upon, well, by me initially, but we'll see an example of how they're used. Number 3, clients. Clients are merely the applications that can request a token from the authentication server. As you can see, they all include a client ID, secret, and a set of allowed scopes. So basically, Colton NopSync API client is allowed only these 3 scopes. So he cannot request Agent Payment Gateway scope. He won't get it. Okay, we limit it here. Yeah, notice here the NopCommerce scope is also up here. So this application has access to NopCommerce. So Colton NopSync can push data to NopCommerce, and NopCommerce is the identity resource that verifies this token with the identity server in this case. Yes, finally down here you can see the allowed grant types. In this case it's client credentials because it's server to server calls. We're not verifying the customers here, right? Makes sense? Yeah, I wanted to say a final note about the PKCE. That's actually proof code for key exchange, or PKCE, whatever you want to call it. This is mainly used for mobile app login, and I'm not really sure why we put it here, so just ignore it. Okay, I don't know why.
One of the Swagger tutorials.
Aha, okay, so Swagger needs this. Good to know.
Maybe the developer was wrong.
Yeah, I mean, like I said, you know, whatever you find online, sometimes it's people agree on this, some they don't. So it's like you don't really know. There's a lot of wiggle room, let's say. It's a fairly new technology. Is there anything you would like to add to this? Anybody? No? You understand everything. Nice. Goody. Okay, next. Okay. Something else you will notice a lot, an additional feature of Identity Server is the well-known endpoints. Okay, this is known as a discovery endpoint, which can be used to retrieve metadata about the Identity Server. It returns information like the issue, the issuer name, like the authorization server name, key materials, maybe supported scopes or endpoints, like if you change your endpoints, etc. So it is available in this /.wellknown/OpenID configuration, and it's always relative to the base address. This is automatic, and that happens with Identity Server 4.0. Yeah.
Just click it.
I cannot click it.
No.
No. But well, if you go there, you will see it's a JSON thingy, and it contains all the information. These are some resources which are also included in your cheat sheet. For those who got it, I hope you got it, right? Okay.
Where's my cheat sheet?
Your cheat sheet.
Geek Squad.
Yeah, see Geek Squad. I can see that.
Anyways, any questions? Oh my God, I explained everything so nice that everybody understood everything.
Can you show the clients in the setup, in the configuration?
If I can what now?
Show the clients in the configuration. Because how does an application now know it's the NopCommerce application? Where,
Does anybody understand this question? Because I don't.
so you have all the scopes, like NopCommerce.
Just go two back.
Oh,
The identity configuration class, I guess.
Yeah.
Here.
Yeah, so you now everywhere have NopCommerce as a scope, but where do you define who's NopCommerce?
Okay, first of all, you define it as an API scope here, and then you go to NopCommerce. Okay, let me show you an example. Oh, how do I get out of here?
Control-Alt-Delete.
Escape.
Huh? Escape, yeah, this is escape. Okay. I need to open, bear with me, huh?
What is this, the Sombrero Nebula or something?
It's not a nebula, that's a galaxy. Hello.
The Sombrero Galaxy, I'm sorry.
The Sombrero Galaxy, yes. Jesus. All right. It's going to take a while to load. Now, I have a couple of examples here in the identity server for those of you who are interested in the tests. Now, you have an API 1, API 2, and the MVC client. Now, the API 2, let's say, this is NopCommerce, okay? NopCommerce that accepts calls from NopSync. So in order to have NopCommerce say to authenticate the tokens, you set it up like this. You say, I have a bearer authentication, it's a JOT bearer authentication, and my authority is this one, and my scope is this. So this is my audience. And this audience can be found, shit, it takes so much time to load. Come on. Okay, bear with me. Hi, Mom. All right, let's see. Yeah. So basically it's here. It's this. No, sorry. Voila. So,
yeah. So in the example API 1.
API 1 would be here. Yes.
Yeah.
API 1 and API 2. Now we have API 2, like I showed. It has this audience. So whoever in his whoever has a token with a scope for API 2 can make requests here. And API 1 has scope API 1, and this one also has a secret. And the MVC client has a home controller, and he creates a request finding the discovery document in the authentication server, and then he creates a token response, which is a password token response, and he's requesting the scope here, you see, API 1. So he wants a token with an addition of access to the API 1. If you remove this, he won't be able to access the API 1. And this is how you protect your APIs. It's usually in the startup. But of course, NopCommerce, I think, does it a bit differently, right? You don't really have a startup. You have some like plugins or.
Yeah, it does have a startup, but the thing with how .NET Core injects its middlware, it needs to be in a specific order. And NopCommerce, unless we modify the source code, prevents us from getting it in the right order, so it crashes.
So yeah, it depends on the. This is a very simple like .NET Core application, right? So most of the setup is done in the startup, but if you take a complicated app, of course, it's going to be done elsewhere, but the basic is the same, right? You add the authentication like this. And by adding this, add authentication and the authority and the audience, then you can have your controllers in your APIs be like this. Oh, that's not protected.
Question. What is the role or purpose of the content provider? Like, what does it serve above standard implementations?
The Colton identity provider, you mean? The identity server?
The token provider in the identity project.
Yeah, wait. It's basically an extension. Let me show it. Yeah, so basically you can request a token. This is how you would request a token from your authentication server. You pass in some information about your client, so your application, your client ID, secrets, and then the scopes that you want. and calling this will return a token. So a token response. You can see what it is. Get an access token, identity token, some scopes, refresh token, an error, or the expiration time. Okay, so in that case, the token provider would be used by the MVC client when it is making a call to one of these APIs. It would have to retrieve a token first, up here, retrieve the token, and then use the token to make the request. So basically, I wrapped all this into one little function that you can use to make the calls. Does that answer the question?
Yes, and just to be sure, there is no functionality in the built-in token provider that would prevent us from using another provider. I guess not. Right?
No, of course not. If you see here, you provide the address, so the token endpoint. It can be anything. It can be Google. It can be Facebook. They all use OpenID Connect and OAuth 2.0. So it really doesn't matter. That's why I showed you those protocols to show that Colton Identity Server actually uses those protocols, and it provides some standardized methods for doing those things. So you can use any extension to do the same thing using our server or another server that's out there, right? As long as the server knows your application, right? You need to register. You need to have a client ID, secret. The secret is usually provided only if it's a code flow, authorization code flow. If it's implicit flow, no secret is provided. So it's only client ID, etc. These are some standards you can find in the resources that I gave you. Do we have any questions? Is everybody burned?
Yes.
That was my goal. So my new name is Mr. VAT OAuth. Joost, it's so funny. You should be a comedian. Anyways, do I have anything more? No. No, I think that's it. Stop it. Escape. How do I escape this?
It's a beautiful end.
No, I had a nice thank you page.
Oh, thank you for joining.
Yes. Wait. Okay, where is it? Where is it? The thank you page. Oh well, I'll just show it here. Thank you.
Oh, very good.
Yeah, right?
What should we do now, Billy?
Now, I don't know. I took the entire hour. When I rehearsed it yesterday, it only took like 15 minutes.
What the hell?
I know, right?
No, it was really good. It was really good.
Thank you.
Yeah. Thank you very much.
And now you're free to go. You're free to do whatever you want.
Okay, bye.
All right. Thanks, Billy. It was nice.
Have a nice
Thank
one.
you.
Joy.
Yeah, thanks for
If
the
you have any questions,
explanation.
you know where to find me.
Yep.
Bye-bye.
Have a good weekend, everyone.
Bye. Nice weekend.
Well.
Bye-bye.
Yeah.
Bye-bye.
Bye.